Okay, so what we have here is a dehumidifier, a little bit dusty, and basically it doesn't work at all. Don't ever buy one of these. They suck. It will not do that right there. It's not going to do that. So I'm going to take it apart because I need the parts inside of it for something. Looks like it's about 25 watts. This is going to be challenging. Let's try the other screwdriver with these. There we go. I'm going to use it to actually control the heat of my house, because there's a component in here that acts as a heat pump. Can't remember the name of it, but I'll put it in there. That way you guys can see it. Okay, there. It's done. Get rid of that. There, that's all the screws. Alright, should pop apart, hopefully. Oh, wait. There's two on the bottom. That almost landed inside of my computer. Whew, that could end badly. Alrighty. Looks like this top part's got some kind of tension because there's no screws up here, so. There we go. It just snaps in there. Okay, here we go. So, looks like will this pop out? No, of course not. Okay. Let's try and get this out. This is the part that's supposed to collect the moisture, and it's supposed to drip right off this fin and land inside of there, but yeah, it doesn't work at all. I think I get like a couple drops in a day, and it's pretty moist in here, so I can literally take this thing, put it inside of my bathroom, and there'll be water collecting on the walls after I take a shower, and it will still not remove moisture from the air, really, whatsoever. I mean, it might a little bit, but the thing is later on, if it's still running, it will literally evaporate out of the small hole right in there. It just vaporizes inside of this thing. So it evaporates at a faster rate than it actually takes it out of the air, which is, it says a lot about this piece of equipment. It's just a scam. Doing this on camera is hard. Yeah. Okay. Part of me just feels like grabbing it and throwing it against the floor a few times and then the plastic just break away from it. But whatever. Let's not do that. That would make a mess. Alright, let's come out. There we go. Okay. So, there we go. Things hot glued onto here. Looks like that cable plugs in right there. Oh wow, look at how simple this is. The lighting is like so bad right now. Hold on. Got my extraordinarily cheap cutters. There we go. Although I probably should have measured the current going through this thing and all that stuff before I took it apart, but whatever. Okay. I'll be able to calculate that out. How is it even getting 12 volts? Because this is not a 12 volt outlet, I don't think. Wait, where's the power supply to this thing? That's a good question. Does this thing have DC going into it? It almost has to, right? Look at that. There's no way that's a AC to DC converter, right? I'll remove the power switch. Tons and tons of screws that are so, in so many ways, overkill for this thing. Like, it's a power switch and there's like 4 screws holding it down. It's unusual for Chinese made stuff, really. Usually it's like 1 screw because they're trying to save money. There might even be a spot for other screws, and literally they will not put a screw there because they want to save money. Or the person assembling it's just a lazy fucker. Not sure which one it is. Okay, there we go. Okay, so we got an LED. We got the in and the out. Oh my gosh, there's nothing on this board. Hold on, I'm going to cut it. Okay, there. And these wires, they're for a switch. Don't need these. Okay. So, we got an on and off switch. It's actually, that's a decent on and off switch. I might be able to use that on something. And it comes with a button. I could probably 3D print something if I work with this. Alright. So, what do we have? We have a resistor and an LED light. Okay, it's got to have a DC input, right? Because I don't even, yeah, I do not even see a diode on here. There's not even a diode, so. Oh, it's got numbers on it. I don't know if you can see those numbers. Hold on. Let's see if I can get it to focus right there. Yeah, there's the numbers. Let's see if we can turn that around and get it correctly oriented. There. Okay, cool. Okay, so very simple stuff. So I bet you it just needs 9 volts and this thing will run and operate this one. I'm probably going to give it like 5 because it does not need to consume 23 watts. So maybe I'll even give it less wattage than that. Okay, let's continue taking this thing apart and I'll show you the component that I'm looking for. And I'll probably use these heat sinks. Well, at least one of them. Something off? Nope. Are you serious? How long do these screws have to be backed out? There. Hopefully that'll work. There we go. Sweet. Okay, cool. Okay, so this is the device. I love the thermal paste on there. That is some good stuff. High quality. We'll make sure we put high quality back on there. Okay. So, this is our, it's not a thermistor. It's a, I don't know. I'll put it in there because I can't think of what it's called. I'm not alone pronouncing it right. Okay. So basically, one side of this will get hot and the other side will get cold. This side right here is the hot side. This side got cold because it's trying to condense the moisture in the air on these fins. So it needs to cool the air in order to get the moisture to condense. So this is the cold side right here, and this is the wiring. And I can just reverse this wiring, and the hot and cold will reverse on this. And what I'm going to do is, well, I'm going to stick it on the thermostat that basically goes on my fireplace. And I'm going to put that part right there, and I'm going to put it in an H bridge and make it so it gets hotter and colder for controlling the temperature in the room. That was pretty cool. It should only change the temperature though a little bit, but it should work just fine. I might keep this fan on here and even have that kind of running on like a low speed. Kind of make sure it gets the air circulated into it, and I'll just sit this somewhere underneath the stove, and then I'll kind of attach and insulate the actual thermometer from the thing, from the actual. That way, it doesn't take as much power to change the temperature, like maybe 10 degrees or something like that. Hopefully, even more. Because if I set it, let's set the thermostat to like 70, or let's say, yeah, let's say like 75, and I just have this pumping out cold. It'll just cause it to click on, and then I can have like an Arduino monitor the temperature, and basically if I have it set to 75, as soon as it becomes well, I don't know. I haven't figured out exactly how I'm going to work it out, but I want it to where normally it would be off, so to where this thing wouldn't have to be running, and then basically to make it turn on, I would essentially just turn the cold down on this. So I might have it to where it's set maybe around 70, and then run it until it's about, or maybe set it to like 68, and then have it run until it's like 70 in the room or something like that, and then this thing can just sit off, and it shouldn't keep the temperature sensor. Well, it's basically a copper tube with a fluid in it that changes and expands with temperature, pushes on a diaphragm inside of it. But So basically we'll get into that, but that's pretty much it for this video, I think. There's nothing else to cover here. So